So, okay, guys, so I'm recording now. If you really, really don't want to be in the recording, don't speak. If you speak, you'll be pulled into the speaker view of the recording. So if you don't want to be seen, just don't speak for the next few minutes, okay? All right, so today you're going to be acting as chemists cleaning out laboratory storage. You have boxes of unlabeled elements, which can be very dangerous. You will use your reference tables and the descriptions of the unknown elements to identify each of them so that they can be properly labeled and stored. So I wish I could say that this didn't happen, but this totally happens. You'll be working in a lab somewhere, you'll open up a cabinet and there'll be a bunch of mystery boxes or mystery jars and you're like, oh no, what's in these? Oh God, you got to figure out what's in them. So it's a bad laboratory practice, but it happens. We make mistakes, right? So you have, your work is going to be done in this page. I know we've been doing some Nearpods recently, but there was just no way for me to make this activity into a good Nearpod. So we're doing it here. And this is another warm-up about converting a temperature scale, but I already showed you that in the little Google form, so I'm going to let you do that there. I'm going to start right here. You're a research chemist at Columbia's Jerome L. Green Science Center in Manhattan. You and a colleague discovered multiple dusty old boxes in a rarely used closet. Inside the box, you find dozens of elemental samples. Unfortunately, the samples are either poorly labeled or not labeled at all. You and your colleague want to use these samples in your lab, so you must conduct tests in order to identify the unknown elements. Given to you are the observations recorded during those tests. Using your knowledge of the periodic table and the element properties, identify each of the unknown element samples. So I'm going to do this example from the slides, and then you guys are going to have two boxes. So here's your first box, 5 samples in it, and our observations from the test that we ran. A second box with 5 samples and observations from the test we ran. Notice that calculations you might need are here at the top of each box. So let's take a peek at the slides real quick, because that's where my example is. We might remember that the reason we have to do temperature conversions are because the Celsius scale and the Kelvin scale are offset. So 200 degrees Kelvin does not equal 200 degrees Kelvin in Celsius. So we have to do a conversion to bounce between them. How do we do that conversion? Well, we take Celsius, we add 273 to it, we get this temperature in Kelvin. So there's another nice look at our Jerome L. Green Center. Okay. So our boxes of elements, let's get into it. So for our first element, we notice that it's a gas at room temperature. It does not react with any substances, and it boils at negative 269 degrees Celsius. So if it boils at negative 269 degrees Celsius, that means that any temperature above that, it's going to be a gas. So that's gas at room temperature. So I can draw some conclusions from this now. First, it's a nonmetal. We know from yesterday's lesson that most nonmetals are either, most metals are not gas at room temperature. So if this is going to be a gas at room temperature, it's got to be a nonmetal. Also, with that really low boiling point of negative 269 degrees Celsius, that's also a pretty good clue that this is a nonmetal. Metals have much, much higher melting points than nonmetals. So, second part says, does not react with any substances. That's another clue that tells me that this is a noble gas. Group 18, the inert gases, they don't react with other things. So I can assume, okay, this is a nonmetal, it's a noble gas. And then I'm told the boiling point. Okay, so this will be really useful because if we go to our reference tables, actually I want to be able to rotate these. So allow me to bring up, there we go. To bring up our reference tables, way down at the end, reference table S. Look at that, we have boiling points. But our boiling points are given to us in K. So we need to convert this boiling point of negative 269 degrees Celsius to Kelvin. So how are we going to do that? Well, we're going to take our equation, Kelvin equals temperature in Celsius plus 273. We're going to add negative 269 plus 273, and we get 4 degrees Kelvin. That is very, very cold, but it's 4 degrees Kelvin is the same temperature as negative 269 degrees Celsius. So now that I know it's 4 degrees Kelvin, now I can find out that it is helium. And I would do that by going to my tables, boiling point, and looking for 4. Where's 4? Where's 4? There's 4. Helium, chemical symbol He, has a boiling point of 4. So I'm able to discover through the reference tables that this element is helium. So quick review. Because it's a gas at room temperature, that tells me it's a nonmetal. Because it doesn't react with any other substances, that tells me it's a noble gas. I use my temperature conversion calculation to turn Celsius into Kelvin, and then I go find Kelvin on my reference table, find that that is helium, element number 4, helium, or boiling point for element number 2, helium, chemical symbol He. Okay, so that's what you're going to do for each of these clues. You got 10 total. Some of them just need some temperature conversions. Some of them in the second box, you're going to need to do density conversions for. So density conversions, you have a mass, you have a volume, mass divided by volume. Again, that equation is in your reference tables. So I hope this is helpful when you guys go to attack this on your own. Probably be helpful to work in groups because there's a lot of papers and a lot of moving pieces here. So it might be helpful to have multiple people working to hold all of the information together because chemists work in teams. All right, guys. Hopefully this is helpful and I look forward to grading it. Okay. And my recording is done.